I am Dr. P. Usharani. Good afternoon. Professor EEE S&H Department, RMD Engineering College. I am going to brief about transistor collector current. In a bipolar junction transistor, we have three configurations: common base, common collector, common emitter. In that, common emitter is preferred generally for practical applications because of few points. Common base is having high current gain but moderate voltage gain. Common collector, if you take high voltage gain, unity current gain. Common emitter, high voltage gain and moderate current gain, which is useful for amplification applications. Even we can say the beta value. Beta value has a high amplification factor, higher value. So common emitter is preferred. And in transistor generally NPN is preferred. Even though PNP is there, NPN is preferred. What's the reason? That is, the mobility of electrons is higher in NPN transistor. That means smooth flow of charge carriers. What do you mean by mobility here? Which is defined as the drift velocity per unit electric field. If you take care of effective mass of holes is more than that of the electrons. If the effective mass of holes is more, that means less mobility of holes. So we are saying NPN transistor is preferred because of mobility of electrons is higher. Now I have taken one example for solving transistor collector current. I have taken the question as a transistor operating in common base configuration, and given data are collector current 2.98 milliamps, emitter current 3 milliamps, and ICO leakage current 0.01 milliamps. What current will flow in the collector circuit of this transistor when connected in CE configuration with a base current of 30 microamps? For that, first they are asking common emitter configuration collector current. The formula for this is beta into IB plus 1 plus beta into ICO, where beta is your common emitter amplification factor. How you are getting this formula? We have to see first one. Next, common base configuration. We have the basic equation of collector current alpha E plus ICO. From this equation, if you simplify, alpha is IC minus ICO divided by IE. So alpha we can get. If you know alpha, we can calculate your beta. Beta is alpha by 1 minus alpha. This is the basic derivation we have known already. So if you know alpha, we can calculate beta. If you calculate beta, we can substitute in this equation and find out collector current. How you are getting this equation? You take a basic equation of IC into 1 minus alpha as alpha IB plus ICBO. Or from this equation, what is your IC as alpha by 1 minus alpha IB plus ICBO divided by 1 minus alpha. We know already beta as alpha by 1 minus alpha. So I can write alpha by 1 minus alpha as beta IB and 1 divided by 1 minus alpha as 1 plus beta. You can take how here you are getting means I have taken 1 plus beta. 1 plus beta as alpha by 1 minus alpha. So in that we should take common denominator as 1 minus alpha means, so here 1 is there, so I am multiplying that 1 by 1 plus 1 minus alpha, so I am getting 1 minus alpha plus this alpha already there, so this alpha I am taken, so my formula becomes 1 divided by 1 minus alpha. That is I have substituted, I have taken this as 1 plus beta. So if you simplify that, 1 plus beta as 1 divided by 1 minus alpha. This only we are using here, this part 1 divided by 1 minus alpha, this part. So that is now 1 plus beta, this equation. So how you are getting that equation? This. So if you know your alpha and beta, we can substitute, we can find collector current. That is the basics formulas. Now I am going to solve this problem using the formulas. So given data I have noted IC value, IE value, ICO and base current values. So I am first step I am going to use finding alpha. The basic equation of IC, which is equal to alpha E plus ICO. From that I am going to find out alpha means, that is from this equation alpha is equal to, if you know we are taking IC minus ICO divided by, we are from this equation only we are writing the second equation, okay, or you can write alpha E is equal to, first step alpha IE is equal to IC minus ICO. Then from this I can write this equation alpha. Alpha is equal to IC minus ICO divided by IE. So I am substituting the given data. IC value is given as 2.98 milliamps and ICO as 0.01 milliamps. So this divided by IE, emitter current as 3 milliamps. All this are milliamps, so we should consider the unit also. So if you simplify alpha, which is 0.99, the answer. You know already alpha value is always less than 1. So whatever we have calculated as less than 1 is correct. Next beta, using the alpha formula, we are going to find out beta. Beta is alpha by 1 minus alpha, which is equal to 0.99 divided by 1 minus 0.99. If you substitute and simplify, 99. So always common emitter beta value is higher. We have mentioned that is one of the advantage why C is preferred. Now we are going for the common emitter configuration. Collector formula as collector current formula beta IB plus 1 plus beta ICO. So I am substituting the calculated values of beta in this formula. So I have substituted the values. After simplification, my answer for collector current is 3.97 milliamps. This is the final answer. Thank you.